All right, guys, so this is 7.6, part 2. Okay, so at the top of the page here, it says to find the length of the period of any sinusoidal function, we can take 2 pi and divide it by omega. So if you have an omega, you have to divide it 2 pi by that to find out what the period is. So the formula is T equals 2 pi over omega. This is very helpful later on. All right, I'm going to go grab a blue pen here. This red is kind of in my face. So the next bit is we have to do objective 3, which is the graph of the cosine function. So what you want to do is pause this video and write down all the values. Once again, x is your angle, and what is your value at that angle. So I'm going to go ahead and fill this out. I too am going to pause. Okay, so I filled out this chart, and because it's super small, I'm going to go ahead and run through all the values. So it is 0 degrees, y equals cosine at 0 degrees. The coordinate point is 0, 1. At pi over 3, we get pi over 3 for x and 1/2 for y. At pi over 2, cosine at pi over 2 equals 0, so it's pi over 2, comma 0. Where y equals cosine at 2 pi over 3, it's 2 pi over 3, comma negative 1/2. And for pi, it's y equals cosine pi, so it's pi, comma negative 1. At 4 pi over 3, y equals cosine at 4 pi over 3, we get 4 pi over 3, comma negative 1/2. At 3 pi over 2, cosine at 3 pi over 2 is 0, so I get 3 pi over 2, 0. And at 5 pi over 3, we get y equals cosine 5 pi over 3, comma 1/2. And then finally, y equals cosine at 2 pi. Cosine at 2 pi is 1. So now that I have all those values, what I'm going to do is I'm going to draw it out, what the graph of cosine x looks like. And then from there, we'll move on through the pages. Okay, so I'm actually going to go back a page. I didn't realize there wasn't enough room. So I'm going to make the drawing of cosine x right here. Okay, what I'm going to do is I'm going to do 3 equal spaces. That's going to be pi over 2. 3 equal spaces. The third one from there is going to be pi. 3 equal spaces, it's 3 pi over 2. And then 3 equal spaces, you get 2 pi. So once again, this is just like sine, with the exception we're dealing with the 60-degree angles instead of the 30-degree angles. So in front of pi over 2, I'm going to plug in pi over 3, because that's 60 degrees. And then right by pi over 2 after it, I'm going to put 2 pi over 3. And then around 3 pi over 2, I need 4 pi over 3 and 5 pi over 3 on both sides. And that should do the trick. So now I'm ready to graph what I have. So I have 1 and negative 1 here. So cosine at 0 is 1. And I'm just going to put a point there. Cosine of pi over 3 is 1/2, positive. And then it goes down to 0. So right now I have this curve. All right, at 2 pi over 3, it's negative 1/2, so it's here. And then at pi, it goes down to 1. And then 4 pi over 3, it loops up to negative 1/2. And then 3 pi over 2, it's back to 0. And then 5 pi over 3 is 1/2. And then finally, 2 pi is back up to 1. So we've made one wave around, which means one period. So the period of cosine is also 2 pi. So that's what the cosine graph looks like. Let's write in what we see. So the domain is the width of the graph. So it's negative infinity to positive infinity, or all real numbers. Okay, because the width, it goes on and on forever in both directions. The range, that's the height of the graph. It goes from negative 1 to 1. Cosine is even, meaning that it has symmetry with respect to the y-axis. Cosine is periodic with a period of 2 pi, just like sine. And the x-intercepts are. The x-intercepts are at pi over 2, and then at 3 pi over 2. So if I'd write the coordinate points, I would have pi over 2 comma 0 and 3 pi over 2 comma 0. That would be the proper coordinate points for the x-intercepts. The y-intercept is the point where it crosses the y-axis. That is 0, 1, and that's found at 0. The maximum value is 1, and it occurs at 0, and also it occurs at 2 pi. The minimum value is -1, and that occurs at pi. Okay, so we have this stuff filled out about cosine, which is important. So now we're ready to actually start doing the transformations. So just like sine, A is the amplitude, and omega is that compression or stretch in the horizontal manner. Okay. All right. So I find the length of the period by t equals 2 pi over omega. So if we have an omega, we're going to have to use that formula. And if there's a negative value in front of cosine, I will reflect the entire graph over the x-axis. Okay, so this means whatever's positive becomes negative and whatever's negative becomes positive. If I have a value added or subtracted from the function, then I have either a vertical shift either up or down. Okay, so what does this look like? This would be a cosine omega x, something like that. And then if I have plus a number, that's what I'm talking about here. We're going to shift the entire graph up. So this will make us shift the entire graph up. So that's what this does. Okay, and then if I have something like this, I'm writing up generically, and I have a minus sign with some value. The minus sign means I'm going to shift the entire graph down. Okay, so that's what those two means. We have not seen those yet, but now we do. All right, also, if there's a number subtracted or added inside the function, then I have horizontal shift to the left or to the right. So a negative means actually shift to the right. It's counterintuitive. And the reason for that is because of its definition. And then a plus means a shift to the left. So once again, counterintuitive. So what am I talking about here? I'm talking about a cosine omega x minus a number. That's going to be a shift to the right. And then if I have a cosine omega x plus some number, that's going to be a shift to the left. All right, so now that we have those written down, we should actually roll some stuff together. If you have something in front of omega, for instance, let's say something simple like cosine of 4x. Okay, I know omega equals 4. All right, so I know the period is not going to end at 2 pi. The reason why is because this graph is going 4 times as fast as what the normal one does. So if omega equals 4, I use the formula t equals 2 pi over omega because I'm trying to find out where the ending point of the period is. Okay, so I put 2 pi over 4. This equals pi over 2. That is my ending point. So that whole period of sine, or cosine in this case, ends at pi over 2. So what does that mean, or how do I graph that? For starters, you need to know the key graph. The key graph is just including 4 points. So those 4 points are pi over 2, pi, 3 pi over 2, and 2 pi. Those are the key graphs. So we have 1 and -1. What does cosine look like? Cosine, the generic graph or the key graph looks like this. So there you go. So that's what I want you to have memorized. That is the graph of cosine, and we need that. So now that we have our 4 key points, we can literally just take and change the points and keep the graph. Why? Because the ending point is now pi over 2, and it's going to behave the same. It's just going to behave the same earlier. So what am I telling you to do? I'm telling you to keep the graph. You know, we have 1 here, -1, right? And we have the 4 key points. So my graph stays the same, so I'm just redoing the graph here. But I need to change my values. Why? Because they're not right anymore because of omega. So instead of writing pi over 2, I need to find that point, by the way. I'm going to put the ending point. Let's do that. So 2 pi, so I have to stop a second. 2 pi was my ending point. It is now pi over 2. Okay, that's my ending point. How do I find the other 4 key points? The first one, I have to divide the ending point, which was pi over 2, by 4. And when I do that, I get pi over 2 times 1/4. That's pi over 8. Okay, so my first value is pi over 8. To find the second key point, you multiply that by 2. So take pi over 8 times 2. And I get pi over 4 when it's reduced. To find the third point, I take pi over 8 times 3. So 3 pi over 8. So once again, to find those 4 key points, you have to find your ending point first. Then to find your first point, you take that ending point divided by 4. To find the second and third points, because remember we already have the end point, to find the second point, you just multiply whatever you got for the first point by 2. And for the third point, you multiply it by 3. And there you go. So this graph here is now the graph of y equals cosine 4x. So once again, the period ended at 2 pi, not at it ended at pi over 2, not at 2 pi. Okay. All right, so that's how you do that. All right, here we go. Graph of y equals 2 cosine 3x. So we got another one to practice with. We have omega. Take care of that. Omega equals 3. I got to find my ending point. So I do 2 pi over omega. My ending point now is 2 pi over 3. Okay, I got to find the 4 key points. So the last point, which is the ending point, is 2 pi over 3. First point, take 2 pi over 3, divide that by 4. Why am I dividing by 4? Because I have 4 key points, just like the original. So this becomes 2 pi over 12, which becomes pi over 6. That's your first point. Second point, take pi over 6, multiply it by 2. So I get 2 pi over 6, which reduces down to pi over 3. Okay, third point. You take pi over 6, multiply it by 3. 3 pi over 6 reduces down to pi over 2. And then your fourth point should be your ending point, but just to make sure, 4 times pi over 6, that's a good check. 4 pi over 6 reduces down to 2 pi over 3. So that is the same as my ending point. So I have my 4 key points. Okay, let's draw those in. So I'm going to draw the generic graph of cosine. The generic graph of cosine looks like this, where this is 1 and this is -1. Okay, now what I'm going to do is draw in my points because I need those. So I'm going to use a different color, such as red. That'll work. So I have 0. First point we said was pi over 6. Second point was pi over 3. Third point was pi over 2. And my last point was 2 pi over 3. Okay, so I got that done. So I've taken care of omega. So this graph is y equals cosine 3x. Okay, now I have to take care of the amplitude. So that's pretty easy. All you have to do is multiply all your values by 2. So I'm going to erase that mark I just made. So what I'm going to do is take a different color here. We're going to draw in the graph we just got. And then I'm going to make sure that I raise everything up by 2. And when I mean that, I mean multiply everything by 2. So if I look at this first key point here, it was 1, 0. 1 times 2 is 2. Okay. At pi over 6, it was 0. 0 times 2 is 0. So that stays put. Okay, and then pi over 3 was negative 1. Negative 1 times 2 is negative 2. And then at pi over 2, it was 0. So 0 times 2 is 0. And then finally at 2 pi over 3, the last point, the value was at 1. So 1 times 2 is 2. So now my graph just looks like it got stretched out. It's taller. So that's what the answer is. So this is y equals cosine, or 2 cosine of 3x. So let's put that down there. Y equals 2 cosine of 3x. Okay, and that is your answer. So this is your answer. All right, for the last one, we're going to show a shift. Y equals cosine x minus pi over 2. I don't have anything going on but a shift. And I know that I'm going to have to shift my graph pi over 2 units to the left, or to the right, excuse me. It's going to be to the right. And the reason why is because this negative is counterintuitive. Okay, so I'm going to draw the original graph of cosine. 4 key points are as such: pi over 2, pi, 3 pi over 2, and 2 pi. By the way, these are just axes values. So here's 1, here's negative 1. So cosine looks like this. Okay, so in blue we get y equals cosine x. Now I'm going to take and draw in red the shift. Okay, so at 0, where x equals 0, y equals negative, or y equals positive 1, I'm going to shift that over pi over 2 units. So now at pi over 2, which I just made a mark there, I get 1. Okay? At pi over 2, I had 0. Now I move that to pi. So now pi 0. At pi, I had negative 1. I move that over to 3 pi over 2. At 3 pi over 2, I had 0. Move it over pi over 2 units, you get 2 pi. And then at 2 pi, if we move it over, it's 1, so it looks like that. So what's my graph look like? My graph looks like this. So if you're telling me right now that, hey, that looks like sine, you're right. So in red, this is sine x. So cosine and sine are very much related. In fact, both are called sinusoidal functions because cosine is literally just a shift to the right pi over 2 units. Okay, and here's a graph of it that's much better looking than mine. So you can see that all the values got shifted at all the key points here. Okay, so the graph, when you shift it, is the one that I'm running on top of here. All right, so if you have a negative sign in front of omega, so if you have a negative omega x, then you have to use the even-odd properties to ensure that omega is always positive. So don't forget to take care of that if that should happen to you. All right, so if omega is positive, the amplitude and period of y equals a sine omega x and y equals a cosine omega x are given by a is the amplitude, the period is given by 2 pi over omega. Okay, we are to graph this function, so we have a lot of stuff going on over here. The amplitude is 4. I know I'm going to, because of this negative sign, I'm going to have to flip everything over once it's done. I also have omega. Omega is pi, which therefore affects t. T is 2 pi over pi in this case, so t is 2. I also have a shift down, so the entire graph is going to go down 2 units, okay? And I would be inclined to do that last. So my advice to you is to take care of omega first. So we found t equals 2, that's your ending point. To find the other 4 key points, I have to divide 2 by 4 to find the first one. And this equals 1/2. So there's point number 1. Point number 2, you take and multiply that by 2. 2 times 1/2 equals 1. 3, I take 1/2 times 3, which equals 3/2. Okay? And 4, just to double check, 4 times 1/2 equals 2. So we know we're A-okay. All right, I got my 4 key points. Let's draw that. So once again, you take the regular function of cosine and you draw it in. Now I'm going to label those 4 key points. 4 key points are 0. First one I found was 1/2 now. Second one is 1. Third one is 3/2. And finally back to 2. Okay, so I took care of this. So my graph right now shows y equals cosine pi x. Okay? I would take care of that flip next. So to flip it over, and I'm going to use a really dark color here and do it on the same graph, whatever is positive becomes negative. So a positive 1 becomes a negative 1. So I'm going to put that point there. 0 doesn't change. A negative 1 becomes a positive 1. 0 doesn't change. At 2, the value is positive 1, so that becomes a negative 1. Because a negative just makes everything flip over or reflect across the x-axis. So right now, the darker graph shows y equals negative cosine pi x. Okay, the last thing I have to do now is take all these points and literally move them down. And I'm going to see if I have a room on this next page to do this. Okay, is this the same function? Let's check. Okay, yeah. All right, so I'm right at this point where I have flipped everything over. And just to remind you what that looks like, the flip was like this. And here's 1 and negative 1. Okay, so that's what we have right at the moment. And this is 2, 3/2, 1, and 1/2. Okay, now I want to take care of the amplitude. The amplitude is 4. So once again, I'm taking all my values and multiplying them by 4. So my graph is going to reach positive 4 and it's going to go down to negative 4. Okay, so at the 0 times 4 is just 0. We'll leave that alone. At 1/2, the value was 0. I leave that one alone. At and I forgot to do 0. At 0, the value was negative 1. Negative 1 times 4 is negative 4. And at 1, the value was positive 1. So positive 1 times 4 gives me a positive 4. And at 3/2, the value was 0. So 0 times 4 is 0. And then finally at 2, the value was negative 1. Negative 1 times 4 gives me negative 4. So this is what the graph looks like. This now shows 4 cosine pi x. Okay, and the negative we took care of already. All right, so I have one more step. Shift everything down, every point down, to values. And why am I choosing 2? It's because it's negative 2. Okay, so we have 4 here, 3, 2, 1, and then negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, so I had negative 4. If I subtract 2 from that, I now have negative 6. So that's a point right there. Okay, at 1/2, I had 0. Shifted down, I now have negative 2. At 1, I have 4. Shift that down, I now have 2. At 3/2, I got the value of 0. Shifted down, I have negative 2. And finally, at 2, I had the value of negative 4, so shifted down, I have now negative 6. So this is all shifted down 2 units. So now the main axis is at negative 2. So all you did was move all these points downward 2 units. That's it. and this is your final graph. So this is a graph of y equals negative 4 cosine pi x minus 2. Okay, last problem, and I know this is getting a bit long here, but I want to get it done. Find the equation for the graph shown. The period is 4. How do I know that? I look at the graph. Okay, I have to find omega. So omega is received if we take t equals 2 pi over omega. Okay, t is 4. We have 2 pi here. We have omega. Solve for omega. So omega equals 2 pi over 4, which equals pi over 2. Okay, got omega. Now this graph, the graph of sine looks like this. The graph of cosine looks like this. And like I said, you have to have that memorized to make sure. So this graph kind of looks like sine, except for it looks like it got inverted. Because this graph that we see looks like what I just have drawn in blue. So remember, this is sine. Okay, so I know there's a negative. There's going to be a negative because it's flipped over the x-axis. We know it's sine. And we know what omega is. Do we have anything else going on here? We do. The height of the graph goes from 2 to 2. So I know my amplitude equals 2. If I didn't have an amplitude, the graph would go from 1 to negative 1 like the normal graph does. So how do I write this up? A sine omega x. Okay, so we know we have a negative that flips it over the x-axis. We know the amplitude is 2. And we know omega is pi over 2. So here is my graph. Y equals negative 2 sine of pi over 2x. And that's how you work it backwards. And that's the end. So congratulations, you just got through 7.6 part 2.